The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today we're going to wrap up section 8.2. But before we do that, are there any questions from yesterday's assignment? I didn't get any requests by email, but is there anything you want to look at before we go on?
Yeah. Sorry. So I understand how to do the fraction ones, but I'm getting confused, kind of.
I need more information.
So for a question that I had on our homework, it was f of x equals 7 over 2x minus 2 when f of x is 2 over 3.
All right, so that scenario?
Yes.
So we're going to take 2/3 and replace f of x with it. So now our equation is going to be 2/3 equals 7/2 x minus 2. And basically we have y, which is right there. We need to find x. So let's see, we can add 2 to both sides of the equation. We'd have 2 and 2/3 equals 7/2 x. Are you okay with that?
Yeah.
All right. 2 and 2/3 would be 8/3 as an improper fraction. Are you okay with that?
Yeah.
All right, so we need to get x by itself. We need to get rid of the coefficient 7/2. So we're going to multiply both sides by its reciprocal, which is 2 7s. On the right side, the 2's and the 7's all reduce down to 1's. We have x. On the left side, nothing pre-reduces, and we have 16 over 21. So there's the value of x that makes y 2/3, or f of x equals 2/3. So basically, f of 16 over 21 equals 2/3 for this function. You okay with that?
Yeah, I see what I did wrong.
All righty. Any other questions before we go on? Okay. Well, first of all, I want to talk about the idea of domain of a function. And we talked a little bit about that yesterday, but consider the following function. F of x equals 1 over x minus 4. And the question is, what is the domain? Well, the domain would be all of the inputs, all of the numbers that we could put into this function and get a real number as an output. Now, the thing we have to avoid in this case is dividing by 0. So we don't want that to happen, okay? We don't want x minus 4 to equal 0. Well, when would x minus 4 equal 0? Well, if we solve this thing, we get when x is 4, because f of 4 would be 1 over 4 minus 4, which is 1 over 0, which is undefined. So this is not in the domain. So the domain x does not equal 4. Now, there's a variety of ways that you could express this. You could say the domain is x not equal to 4. Or you could say the domain all real numbers except 4. There's a third way, and that's the way I want to focus on today. It's called using interval notation. And interval notation is first introduced in the textbook back in section 2.7, which would have been from a previous class. But if you want to look in the textbook in section 2.7, it talks about it. But I want to talk about how we would write this using interval notation, okay? I'm going to go on to the next screen for a minute. So we want to say that the domain is that x is not equal to 4. Okay. First of all, if we say this, that would be all real numbers from negative infinity to positive infinity. We don't put, or I should say, we put parentheses on both ends because there is no definite endpoint negative infinity and positive infinity. But what we want to do is we want all real numbers excluding that. So we're going to start at negative infinity, go up to, but not including 4, along with starting after 4 and going to positive infinity. So that is the way, using interval notation, that you would write all real numbers except 4. Any questions on this specific example before I go on? Okay, let's take a look at another example. Here we have h of x equals 3x plus 6. And again, the question is, what is the domain? Well, there's no variable in a denominator situation here. So there's no value of x that is going to make this thing undefined. So there's no restrictions. So the domain would be all real numbers, everything from negative infinity to positive infinity. And again, we use parentheses to say that there isn't specific endpoints. Negative infinity goes negative forever, positive infinity goes positive forever. Okay. Let's take a look at another example. F of x equals 5 over x plus 1. Well, we now have a variable in the denominator, so there's a possibility of the denominator equaling 0, which we want to avoid. So we don't want x plus 1 to equal 0. So we don't want x to equal negative 1, because f of negative 1 would be 5 over negative 1 plus 1, which is 5 over 0, which again is undefined. So we want to say that. So the domain would be from negative infinity up to, but not including negative 1, skipping over negative 1, after negative 1, up to positive infinity. So it's all real numbers excluding negative 1. Any questions on that problem?
So we don't do it like the f of x, we solve for x on the other side instead?
I'm not sure what you're asking. Can you say that again?
Okay, so how you did the 5 over 1 or negative 1 plus 1, and then x gonna equal to 0. So we don't do it that way. We do it x plus 1.
Well, so where would you come up with negative 1? If you can just look at that and say, oh, I can see that if x is negative 1, we're in trouble, that's great. But if things get more complicated, basically take the denominator, set it equal to 0, and solve for it. Let me throw another one at you and see what you think of this one. Maybe this will help. Okay. Let's see. F of x equals 15 over 1 minus 3x. Okay. So what's the domain?
The all the numbers on the bottom, or all of them.
So is there any value of x that wouldn't be in the domain?
No.
But there is. Okay. What about f of 1/3? That would be 15 over 1 minus 3 times 1/3, which would be 15 over 1 minus 1, which would be 15 over 0, which is undefined. So the domain does not include 1/3. X does not equal 1/3. Because when x is 1/3, we're dividing by 0. Well, if you can't just look at that and see that, how would you come up with that? Well, if you said 1 minus 3x, the denominator can't equal 0, okay? So subtracting 1, negative 3x can't equal negative 1, divide by negative 3, x can't equal 1/3. If you can't just look at it and see it, this is how you'd come up with that. Is that making any sense?
Yeah.
Okay. And how would you say that in interval notation? Negative infinity up to, but not including 1/3, not including 1/3 up to infinity. Okay. I want to go on to the next part of this last section, which is to graph functions. So I'm going to switch to the other screen, which has graphing on it. And okay. Let's take a look at the function f of x equals 2x minus 1. Okay, let's see if I can write that. Not so sloppy. It's giving me issues today. It was working just fine a little while ago. Oh, well. Okay. This is supposed to be f of x. All right. This function is in slope-intercept form. Y equals mx plus b. Sometimes this screen doesn't cooperate, and I actually checked it earlier today, and things were working fine. So I don't know. I'll just have to live with it. Okay. Okay, come on. You know what? If it's going to be that way, we will just do this. We'll go back to the other screen. Okay. Don't panic. Okay. I have a backup plan for when this happens. I said I checked it like half an hour ago and it worked just fine. Okay, here's our backup plan. So we have f of x equals, what was it? 2x minus 1. Can everybody see my screen that I'm writing on?
Yes.
Yes.
Okay, all right. This is in slope-intercept form. Y equals mx plus b. So the slope of the line is 2 and the y-intercept is negative 1. So the y-intercept is negative 1. The slope is 2, so we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And then we will draw a line through those points. And there is the graph of f of x equals 2x minus 1. It's the same graph as if we graphed y equals 2x minus 1, because recall, f of x is the same as y. We just use that notation when it's a function. All right? Any questions about that equation, about that graph of that function? Okay, let's take a look at another one. This says f of x equals 2/3 x minus 2. So now using the form y equals mx plus b, the slope is 2/3 and the y-intercept is negative 2. So we begin with a y-intercept of negative 2. We go up 2 and over 3, up 2 and over 3. Let's see here. And here is the graph of f of x equals 2/3 x minus 2. Any questions about that? Now, in WebAssign, in fact, let me just walk you through it here. In WebAssign, what you're going to do, remember how we graphed inequalities back before the first test, okay? And we did it by graphing lines, all right? We're gonna do the same thing. So what you're gonna do is, let's see, in WebAssign, let's go back to this. You're gonna have a grid, and then over here, you're gonna have a bunch of buttons, okay? And there's a button that has a line on it, okay? And you click on it till it turns blue, and it's the same button that we used when we graphed linear inequalities. And then you're gonna click on the graph on a point and then on another point. And when you do that, then it's gonna form a line, okay? You only need to plot 2 points. Don't use the one that has the dot on it. Use the one that has the straight line, okay? Anyway, we'll see if you run into issues. I'll hear about it if you do. Okay. Now, the next stuff we're going to look at, I'm going to actually review. This is kind of a review of chapter 3, which is graphing. And there's 10 important ideas that I want to review because we're going to be using many of them in the rest of this section. Okay. First of all, to find a y-intercept, set x equal to 0. So in other words, complete that ordered pair. So if you have some equation, 2x plus 3y equals 12, and you want to find the y-intercept, if you put 0 in for x, plus 3y equals 12, 3y equals 12, divide by 3, y equals 4, okay? So to find a y-intercept, you set x equal to 0. What is the y-intercept? That's the point on the graph on the y-axis where the graph cuts through. So that's the y-intercept, okay? Any questions about that? All right, so we'll call that number 1. Number 2, to find an x-intercept, set y equal to 0. So complete that ordered pair. So let's go back to our 2x plus 3y equals 12 or whatever it was. So now I'm going to let y equal 0. So 2x equals, slow down. 2x equals 12, divide by 2, x equals 6. So, and the x-intercept is where it cuts through the x-axis on the graph. All right? So those are y-intercepts and x-intercepts. Any question about those? All right. Number 3 is the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if you have a graph that passes through, let's say the points 2, 3, and -5, 7, okay? And you want to know the slope of the line that passes through those 2 points. This first point is 0.1 and the second point is 0.2. These little numbers here are subscripts. So 0.1 has x sub 1 and y sub 1. 0.2 has x sub 2 and y sub 2, okay? So y sub 2 would be 7. Y sub 1 is 3. X sub 2 is -5 and x sub 1 is 2. Doing the arithmetic, 7 minus 3 is 4. -5 minus 2 is -7. So we'd rewrite that as -4 over 7. So the slope of the line passing through those 2 points would be -4/7. Any questions about that? Okay. Number 4, SlopeIntercept Form. Y equals mx plus b. That's what I was using graphing the last couple of problems a little bit ago. So if you have an equation, let's take the 2x, let's go 2x plus 4y equals 8. If I solve it for y, so I'm going to subtract 2x, 4y equals negative 2x plus 8. I'm going to divide everybody by 4. So I get that. So the slope of that line is -0.5 and the y-intercept is 2, which means it would start at 2 and then it would go down 1 and over 2, down 1 and over 2 to graph it. Okay, and I'm just kind of slopping out a graph there, but to give you the general idea. So that's the slope-intercept form. Any questions about that one? Again, these are all in chapter 3. If you want to go back and review them, this would have been in Math 85 or in a beginning algebra class. That's 4 down, 6 to go. All right, item number 5. Parallel lines have the same slope. So let's say that line 1 is parallel to line 2. If the slope of line 1 is 2/3, the slope of line 2 is also 2/3. There we go. Okay. Parallel lines have the same slope. Also, we could say if 2 lines have the same slope, they're parallel. So for instance, y equals 3/7 x plus 5 and y equals 3/7 x minus 2. Since these have the same slope, the lines are parallel. And those 2 little parallel lines is the symbol for parallel lines. Okay? Questions there? All right. Number 6. Perpendicular lines have slopes that are negative reciprocals. So let's say that line 3 is perpendicular to line 4. That's the symbol for perpendicular. They meet at a right angle, okay? If the slope of line 3 is, let's say, 2/5, the slope of line 4 would be -5/2. Okay, so if 2 lines are perpendicular, their slopes are negative reciprocals. Likewise, if 2 lines have slopes that are negative reciprocals, the graphs would be perpendicular. 6 down and 4 to go. All right. Number 7. Let's see here. An equation in the form y equals a constant, as in y equals a number. This is, let's see, equation in the form is a horizontal line. So the graph is, it's a horizontal line. So let's say you've got the equation y equals 3. That's going to look like that. It's going to be a horizontal line passing through 3. What if you had f of x equals 3? Remember, f of x is just a fancy name for y. So this would also be the graph of f of x equals 3. So an equation in the form y equals a constant, the graph is a horizontal line. Okay. Number 8, the equation, let's see, of the form x equals a constant, the graph is a vertical line. So let's say you've got x equals -2. Okay, so that would look like, oops, kind of missed it there, like a vertical line, x equals -2. You couldn't write that as a function because y isn't in the equation. All right, that's 8. Now, number 9, the slope of a horizontal line is 0. Okay, and 10, the slope of a vertical line is undefined. And let me exemplify both of those here. All right. So slope is rise over run. Or if it's negative, we could say fall over run. So if I have a horizontal line, the rise or the fall is 0 over some run. So the slope would be 0 over some number, let's say 7, which is 0. So the slope of a horizontal line is 0. If I have a vertical line, the rise, let's say we go from here to here, the rise might be 3, but the run is 0. And dividing by 0 is undefined. All right, we're going to use those 10 rules, at least in part, on this next bunch of problems. So here we go. It says, write an equation for a linear function. So we're going to use function notation, whose graph has the given characteristics. All right, it has a slope of 5 and a y-intercept of 0, -3. Okay, now, slope of 5. So that means that m, which is the letter we use to represent slope, is 5. And b, the letter we use to represent the y-intercept, would be -3. We can plug that into the form y equals mx plus b, the slope-intercept form. So we would get y equals 5x minus 3. You could write plus -3, but it's cleaner to just write -3. But we want it to be a function. So we're going to say f of x equals 5x minus 3. That has a slope of 5 and a y-intercept of -3. Any questions on that particular problem? Okay, let's take a look at another example. This one has a slope of 1/5, and it passes through the point 10, 1. All right, now, I know that the slope is 1/5. However, this is not the y-intercept. I know that because if it was a y-intercept, x would have to be 0, like back in this previous problem. X is not 0, it's 10. So I don't have the y-intercept. But what I can do is this. Using y equals mx plus b, I can take the slope and put it in for m. So then I get that. Any questions so far? Now, I need to find the y-intercept. What I can do, I can take this ordered pair, take the 10, which is the x value, and put it in for x. Take the 1, which is the y value, put it in for y, and we get 1 equals 1/5 times 10 plus b, which means 1 equals 2 plus b. 10 over 5 reduces to 2 over 1. subtract 2 from both sides, and b equals -1. So now I have m and b. So y equals 1/5 x minus 1. Using function notation, f of x equals 1/5 x minus 1. That has a slope of 1/5, and if x is 10, f of x or y equals 1. Any questions on that? Okay, let's take a look at another example. Here we want the equation for a linear function that passes through the following 2 points, 1, 7, and -2, 1. Again, we need the slope and we need the y-intercept. In this case, they haven't given us either one. But if we use the slope formula, that will give us the slope. So if this is 0.1 and this is 0.2, y sub 2 is 1, y sub 1 is 7, x sub 2 is -2, and x sub 1 is 1. Doing the arithmetic, 1 minus 7 is -6, -2 minus 1 is -3. This simplifies down to 2. So the slope is 2. Okay, so now I know the slope, but I don't know the y-intercept yet. Well, this now is kind of like this problem we did where we had the slope and a point. Now we've got the slope and 2 points. So using y equals mx plus b, 2 goes in the place of m, y equals 2x plus b. I have 2 ordered pairs up here, 1, 7, and -2, 1. I can use either one of them, but I have to use just one. Don't take an x from one of the points and a y from the other point, okay? I'm going to use this point. So 1 goes in the place of x, and 7 goes in the place of y. So 7 equals 2 times 1 plus b. 7 equals 2 plus b. Subtract 2, b equals 5. So now I've got the y-intercept and the slope. So y equals 2x plus 5, writing it as a function, f of x equals 2x plus 5. Now, let's check our work. If this is true, both these ordered pairs should be solutions. If x is 1, 2 times 1 is 2 plus 5 is 7. So 1, 7 works. If x is -2, 2 times -2 is -4. -4 plus 5 is 1, so it checks. Any questions on this problem? All right. Next one. This equation, or the graph, it says it passes through 3, 0, and it's parallel to the graph of g of x equals -2/3 x minus 4. All right. So parallel lines have the same slope. What is the slope of g of x? That slope is -2/3, which means the slope of the line we're looking for is also -2/3. Okay, parallel lines have the same slope. So now I've got y equals mx plus b. M is -2/3, so y equals -2/3 x plus b. I'm going to take the ordered pair that I was given. 3 goes in for x, 0 goes in for y. I get 0 equals -2 plus b. Add 2 to both sides, b equals 2. So I've got the slope and the y-intercept. Y equals -2/3 x plus 2, writing it as a function, f of x equals -2/3 x plus 2. Notice it has the same slope as the line it's parallel to, so that's a good thing. Any questions there? All right. Now we have a line that says it passes through 1, 2, and it's perpendicular to the graph of g of x equals 1, let's see, negative x over 6 plus 1. All right. Whereas parallel lines have the same slopes, perpendicular lines have slopes that are negative reciprocals. So if the slope of this line is negative 1/6, keep in mind there's an implied 1 there, then the slope of the line perpendicular would be 6 over 1, or just 6. The negative reciprocal of negative 1/6 would be positive 6 over 1. Okay, so now we've got the slope, y equals mx plus b. 6 goes in the place of m. Y equals 6x plus b. We have a point that's on the new line. X is 1, y is 2. 2 equals 6 times 1 plus b. 2 equals 6 plus b. Negative 4 equals b. So y equals 6x minus 4. F of x equals 6x minus 4. Notice the slope is the negative reciprocal of the g of x slope, so at least we know at this point it's the right slope. Any questions on that one? All right, I know I'm moving along at quite a pace here, but fortunately you can go back and look this over at your own pace later. Now, we want the equation of a horizontal line that passes through negative 8, 12. Well, one of those 10 items that I gave you was that the equation of a horizontal line is y equals a constant, or y equals a number. So the horizontal line is going to be y equals, well, what is the y value for this ordered pair? 12. Or f of x equals 12. Now, let's do this graphically. So the point negative 8, 12 would be over here somewhere, okay? We're just gonna say that's negative 8, 12. Horizontal line would look like that. So it would be y equals 12. All the points on this line have a y value of 12, and ultimately as a function, f of x equals 12. All right, with that, okay, I know some of you are feeling overwhelmed right now. You can do this. There's just a lot of information there. All right, let's take a look at this situation, okay? It says nurses. The demand for full-time registered nurses in the United States can be modeled by a linear function, okay? So f of x equals mx plus b. In 2005, approximately 2 million, and don't freak out about all these numbers, I'm gonna write them down here eventually. In 2005, approximately 2,175,500 nurses were needed. By the year 2015, that number is expected to increase to about 2,586,500. Now, it's already past 2015, so this is an old problem. Okay. It says, let T be the number of years after 2000. So T, the variable T, equals number of years after 2000. And N be the number of full-time registered nurses, so number of full-time registered nurses needed in the US. It says write a linear function N of T. Now, what this tells me, among other things, is that T is the input because it's on the inside, and N is the output, okay? So our ordered pairs are going to be in the form of T, comma, N. What I'm going to do is I'm going to extract two ordered pairs from the story. From those two ordered pairs, using techniques we've covered here a little bit ago, I'm going to get the slope of the line and then finally the y-intercept, which will give me the equation describing the situation involving the nurses. Okay, now let's go back here. It says the demand for full-time registered nurses in the United States can be modeled by a linear function. In 2005, approximately 2,175,500 nurses were needed. Well, if T equals 0 in the year 2000, because T is the number of nurses, or T is the number of years after 2000, 2005, you'd have T equals 5. So 5 years after the year 2000, how many nurses are there? 2,175,500. Okay, so there's one ordered pair. Then it says, by the year 2015, so that's 15 years after the year 2000, that number is expected to be 2,586,500. So 5 years after the year 2000, we've got 2,175,500. 15 years after, we've got 2,586,500. Okay, so those are our two ordered pairs, 0.1 and 0.2. Using the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, even though my ordered pairs are technically t and n, I can still think of them as x and y. So I'm going to get y sub 2, which is 2,586,500, minus y sub 1, which is 2,175,500, all over x sub 2, which is 15, minus x sub 1, which is 5. Do you have any question about where I got any of those numbers? Okay, so I'm going to pull out my calculator. 2,586,500 minus 2,175,500, and I get 411,000. 15 minus 5 is 10, so that's going to get rid of a 0. So we're going to get 41,100. So the slope is 41,100. Okay. Now, I'm going to need another page for this problem. So I'm going to go to the next page and I'm going to copy my two ordered pairs. Let's see, 175,500. And then this was 15, 2,586,500. 586,500. We already concluded that the slope was 41,100. Okay. So using y equals mx plus b, that goes in the place of m. Y equals 41,100 x plus b. I'm going to use one of the ordered pairs. I'll use this one. 5 goes in the place of x. 2,175,000, 5 goes in the place of y. So I get 2,175,500 equals 41,100 times 5 plus b. I'm doing the same thing I did earlier with a problem where we had two ordered pairs. 2,175,500 equals, let's see, if we take 41,100 times 5, we get 205,500 plus b. We're going to subtract 205,500 from both sides. So 2,175,500 minus 205,500 and I get 1970000 equals B. Okay, well, I've got M and I've got B. So Y equals 41,100X plus 1,970,000. However, I'm going to take that and copy that on the next page. Y equals 41,100X plus 1,970,197,000. Recall that it was N of T. So N of T equals 41,100 T plus 1,970,000. So there's our function written with the correct variables, okay? I know, a lot to do with this problem. One more step and then we'll be done for the day. Use your answer in part A to predict the number of full-time nurses that will be needed in 2025. All right, so 2025. How many years after 2000 is 2025?
25.
25. So we want to find N of 25, where T is 25. So that's going to be 41,100 times 25 plus 1,970,000. And I've got 41,100 times 25 plus 1,970,000. And I'm getting 2,997,500. So almost 3 million. 2,997,500. All right, so in this problem, we had to read the information. We had to see that, oh, time is measured after the year 2000. So 2005, time was 5 years. 2015, time was 15 years. At the end there, 2025, time was 25 years, okay? And then N was the number of nurses needed. So our function was N of T. We went in and extracted two ordered pairs, found the slope, found the y-intercept, got the equation, used the proper notation using T and N, and then answered a follow-up question. All right, I know that's a lot to take in today. I will be back at 1:15 with an office hour if you have any questions. Otherwise, have a good day. I would strongly recommend you getting familiar with those 10 rules that I listed. Okay.